When the function is in the form of ax minus h squared plus k, then we can get a few things. One, we can get the vertex of that function, and that is usually given by the value of h and the value of k written as coordinates, that is hk. It is also possible to read off the axis of symmetry, and that's the value of x at that vertex. And we can also evaluate the value of the y-intercept, that's a value of y when x is equals to 0, which is basically a times h squared, negative h, same thing, and then we add k. Now we're going to start with a function that is actually not in that form. Say we have a function f of x is equals to negative 2x squared plus 8x plus 6. So the first thing is to try and convert it into that form. Step number 1, I would like to factorize the negative 2. So that would be negative 2. That leaves me with x squared minus 4x plus 6. Now I want to complete the square in that part, and I do know that x squared minus 4x comes from part of an expression which looks like that, x squared minus 4x plus 4, which is actually x minus 2 all squared. So if I do replace x squared minus 4 by x minus 2 squared, then I do know that I have actually replaced it with x squared minus 4x plus 4. Now that 4 there is going to be an extra value that we need to take care of at some point. But at this point, I would like to replace this with x minus 2 squared, and that is equivalent to all that. So to make it what I want it to be, which is x squared minus 4x, I need to take away that 4 out there, and the final part is 6. When I open this, I can rewrite this as negative 2x minus 2 squared plus 8, of course, because minus 2 times negative 4 is positive 8, and then plus the 6. That should leave me with the expression f of x being the same thing as negative 2x minus 2 squared plus 14. And that means that in the turning point form, that function f of x is equals to negative 2x squared plus 8x plus 6 is the same thing as that. That means the vertex is it's positive 2, 14. The axis of symmetry is x is equals to 2, and the y-intercept is negative 2, which is 6, and I multiply those out. Now with that in mind, I can sketch the graph of my function. That graph should look something like this. I know that the axis of symmetry is x is equals to 2. The vertex is 2, 14. Because a is negative, the value of a is negative 2, I know that my graph will have a maximum turning point, and the y-intercept is x is equals to 6. So the sketch of my graph will be probably something like this. Not the best sketches, but will do for now. With the main features, that would be the sketch of the graph that we started with.